Having started.
Hi, everyone. Welcome to Chapter 7. And Chapter 7, we're going to be dealing with a new type of program unit called a package. And packages actually have several advantages to just using functions and procedures and different things like that on their own. A package is basically a container that holds multiple program units. So we would create a package that might contain, 5 procedures, 10 functions, and for some reason they would all be related to some type of functionality. Maybe they all represent things that are done on one screen in the application. So they all are pieces of the puzzle for that screen, that front end screen. There's different reasons why you would use packages, but if we look here at the functionality and what they really give us, there's 5 different things listed here. First of all, we can have private program units versus public, and we'll talk a little bit later what that means. We can share variable values. Okay, let's say, go back to where I was talking about a minute ago. Let's say that an application, the front end screen, is going to interface with our database, and we're going to have the user put in some input. Well, the user would kind of expect us to save that input, even if it's used by different procedures and different functions. So we can actually share that variable value that's input once by the user to our different procedures and different functions if we are using them inside of a package. So that's another added feature or added functionality that packages bring to the table. Overloading, we're going to talk about that today and look at an example. Overloading is where you can actually have more than one of a procedure that have the same name. And it's very useful for lots of reasons, and we'll explore that a little bit later as well. Easier privilege granting, it actually makes security work a little bit better because we can actually have functions and procedures run based on the package security level that we grant a user versus having to grant privileges for every single procedure and every single function. And it can improve performance of your system because it can basically load variables once instead of multiple times. And in the book, if you read toward the end of the chapter, has some other examples of where and how it improves performance when you use packages. But those are the basic reasons. They also, if you look at the introduction to the chapter, chapter 7, at the very top of page 250, they kind of walk through an example of what the Bluebeam development group is wanting to solve some new problems, and they list the problems. And really all of those reasons go back to this added functionality that packages. So they're all reasons why you would use a package. So take a look at that as well if you want a little bit of extra understanding on why we would use a package. Packages have 2 parts. A package has a specification, and a package also has a body. And these are both separate program units that we create inside of our database, and we'll look at the purpose for both of them. The package specification, first of all, is really where we declare all of our program units. So it contains the declarations for the program units, any variables that are used throughout the whole package. You can also define exceptions that are valid for the entire package inside your specification. You can basically create any cursors that you want to use for the entire package, and also any data types, custom data types that you want to create and use for the entire package. So that's the types of things that you would put in the package specification. Oftentimes we look at or think of the package specification as the package header, okay? Now, when we declare program units like procedure or a function, notice the second bullet point there says we declare them with the header only, meaning that we don't put our entire code for the procedure or the function inside the package specification. You'll see in a minute that that actually goes in the package body. All we do is basically the declare section of those program units. Order of declarations is important inside of your package specification, especially if one of your program units refers to something else in the specification. You've got to make sure that anything that's referred to inside of one program unit has already been declared in the package before you get to that. So basically, Oracle or your database reads the declarations from top to bottom. So they need to be in order such that when it gets to something that's being referenced that's part of the package, it's got to know it exists. So if it's below where you are, then obviously it doesn't know it exists yet. So order of declarations is very important. Here's an example of a package specification, and I believe the same item or screenshot is on page 251 at the bottom of the page. And if you look here, just like our create or replace procedure and create or replace function statements, we start off the same way, create or replace, only this time we use the word package. And package by itself, that word by itself means that it is the package specification that we are actually creating. Then we give a name to our package. Notice that this textbook is using an underscore PKG to stand for package, just so that, just as a naming convention, just like we did underscore SF for stored function, for example. We use the is, just like we did in the other program units that we've learned. And then we would declare any variables that we're going to use inside the package. And then you can see this one actually has one package variable, and they're using the name of it is PV underscore total underscore num. And then it obviously gives the data type for the package variable name. The package variables, notice they're using that PV underscore as the prefix, so that we know that that's a package variable. Okay. The next little section here, if we look, let me get my little drawing tool here. We've got from here to down here. Here is our procedure. And again, because this is the package specification, we're only doing the header of the procedure. So if you think about what the header of the procedure is, it's the name of the procedure, and then in parentheses, all the in and out parameters. So when we identify them, obviously, whether they're in or out, and give them a name. And remember, we're using the P underscore for a procedure variable name. And then we've got number as the data type for all of those. And then the next thing we see in our package specification is our function header. This function is called ship underscore calc underscore. And notice it has a extension of PF. Instead of SF for stored function, it's PF, meaning it's a package function. I didn't point that out up here in the procedure. Notice that its suffix is underscore PP for the name. So package procedure. So just again, some naming conventions so that we can quickly look at these things and identify the name of something with what it is. So anyway, our function has one in parameter of the quantity, and then it returns a number. So again, just the header of the function is in the package specification. Now, the next thing that a package needs is a package body. And the package body, the purpose of it is this first bullet point. It's what contains the entire program unit code for anything that's declared in the specification. If it's in the specification, it must be in the body as well, as far as a program unit, like a procedure or a function. There can be variables that are mentioned in the package specification that are not in the body, but anything that is another program unit, like a procedure or a function, if it's in the package specification, it must be in the body. But this is where the actual entire block goes. Now, we're going to see in a minute that the program unit name is actually used in the end statements to make it more readable. So when we look at this package body, it's basically going to be a string of different PL SQL blocks. And so we're going to have a procedure, then a function, then another function, then maybe another procedure. And, each one of those sections ends with the word end. That's what ends that block. So to make it more readable and know what is ending, often you'll see the program unit name repeated in the end statement. And we'll point that out to you in a second when we look at the example. Now, the last thing it says here is that you can declare new constructs that aren't in the specification. However, these can only be used inside this package. These would be called private constructs. So we could have private variables that are in the body that are not in the specification. We could have private functions that are in the body but not in the specification. And that would mean that only the package itself, like another procedure or another function inside the package, could call that private variable or function, for example. If you were outside of that package, you could not call it. So that's the difference between public and private. Now, they do a really good job in the textbook talking about public and private and even go through an example. So pay particular attention to that when you're reading through the chapter. Now, package body, this screenshot actually shows you creating it in SQL Server using the right-click method. You create the specification first, and then you can right-click on the specification, and then you can create the body of the package. Now, let's see. We have an example. Oh, no, I don't have a package body example. I'm sorry. Let's see. Let's look at one. If you'll look in the book with me on page 253. Basically there you've got a good, where you see the specification at the top and the body underneath. And if you look there, you can see what I was talking about. In the body, we've got create or replace package body. Okay. The word body is added to show that that's the package body create or replace statement. And it should have the same name as the specification. And then this is where we just start putting our blocks of code one after another. So first we have a function, then we have a procedure, and then actually that's all that's in this body. So if you look at the first function, you can go down through there, you see the is, begin, so we see the begin section, then we have an end if, and then return our variable, and then we have end ship underscore calc underscore pf. And that is actually where you see the name of the function used in the end statement. So we know we're ending that function. Then the next line we see procedure, and that's where the procedure header is, and then we have the begin section. And again, in the end statement, at the bottom of that, we have end order underscore total underscore pp. So that shows you the end. Again, the procedure name used in the end statement. So it just makes it more readable if you do that. Now, let's see. If we look here at this screenshot, this talks about actually calling packaged program units. Before, we would just, name the program unit and then in parentheses put the arguments. The only difference between a standalone and executing a packaged one is that we add the package name before it, separated by a dot. So it's package name dot program unit name, and then in parentheses we put the arguments. And the same thing with variables. If you want to reference a packaged variable, it would be package name dot variable name instead of just variable name by itself. So that's fairly straightforward. Only thing we're adding is the package name dot before what we're used to doing. Here's an example of invoking our package constructs. So if we look here, we've got a declare. This is just an anonymous block that we have going on here. And we've got some variables that we've created, local variables. And then we're basically executing a procedure that's in the ordering underscore PKG. So that's the package name. Let's see. Let me go ahead and let me get my pen. Let's do a red. So we have right here package name. Okay, we've got package name. Whoops, I'm not very good at drawing, sorry, on here. But anyway, we've got package name and then dot. Let me erase that and try again. Here's the package name. Okay, and then you can see there's a dot. Okay, and then there is the name of the procedure that we're calling. Okay, and then of course all of the variables that are needed. We need to supply all the formal parameters that we need to supply to the procedure for it to execute. And then we got our put lines to actually just put those values out there. So you can see it live in action actually being invoked. Now, this goes back to this slide, and this part of the chapter is where I was talking about, they do a really good job talking about public versus private. If it's public, it's referenced inside, can be referenced from inside or outside the package. And that's only for any constructs that are declared inside the specification. If it's only in the body, then it's considered private, and it can only be referenced by other constructs within the same package body. So, like I said, take a good look at that section so you make sure you understand that. And I think they have a good example for you to walk through too, step by step. Now, by default, package constraints or constructs that are declared in the specification, as we said, they're what's called global or they're public. The other thing, besides being public, the global really means that the value persists throughout a user session. So each user session maintains the separate instance of the packaged variable or construct. So basically, this goes back to our first benefit of using a package, where we can actually get input, say, from our user for a variable, and then we can hold it through that entire user session. And it can be used inside the package over and over by different procedures, different functions, and the user never have to input the value again. Now, what defines a user session is actually what's key here. A user session is when a user logs on to the application, then basically, the way the front end interacts with the back end is it will go create that session on the database as well. And then while that user's logged on, that would be considered one session. Now, if they log off or that session ends, if it's for example, a web app, it might be just when you close the web browser, then that ends the user session. But whatever ends your user session is what actually terminates that value being continued, in the database, being held in memory. So then you start over again. Let's see, and they have this example of a user logging in, and they call a procedure that sets a package variable to 0, and then at 10 o'clock they call another procedure that sets the package variable to 5. Then the user logs off for lunch. When they log back on after lunch, the package hasn't been referenced yet, so the variable of that package variable is set to null at that point because it's reset because the user logged off. And over here we've got user B. They actually logged on at 10:30, which is while the first user was on there, but they have a separate area of memory that's holding their user session, so their variable can have a different value than the variable being used by user A. So basically, each user session can have these packages held in memory for them specifically, and it can hold values for these different variables that are in the package. Now, some notes here, a package specification, it says the specification can exist without a body. So this is another characteristic of a specification. If it's used without a body, then it's often used to store reference static values. And if you look here, the example they talk about in the book is, say, for example, a lot of our calculations are based on metric or US to metric conversions. And you want to have that conversion rate basically at hand anytime you need it for a calculation. So you can actually create a package that would store those constants. So a cup to liter conversion is 0.24. A pint to a liter is 0.47. A quart to a liter is 0.95. And then basically these are just constants that anytime we're in another procedure or another function and we need to do a quart to liter calculation, we could just go call, this is called metric underscore package. So we go call metric underscore package dot quart to liter. And then we would automatically be given the value 0.95. So a great way for static variables or values to be stored in your database, and so they can be referenced by functions and procedures as needed. Now, forward declarations, we're going to look, actually I don't have an example to look at for a forward declaration, but the idea of a forward declaration is that we might have some private program units, and if you have a private program unit, that means that they're often referenced by another program unit inside the package. And if that's the case, remember we talked about the order of everything being declared in the package is important. Well, it's the same thing in the body. You can't use something that's private until it's been read into the system. If it's actually in the package specification, then it's read in and known about immediately. But since private program units are not in the specification, then the order that they appear inside the body actually matters. And sometimes we try to organize when packages get really big. I mean, if we were in a real live application environment, we might have 100 program units inside of a package very easily. And sometimes it gets very hard for the developers to try to find specific packages or program units, I should say, inside the package. So a lot of times they'll alphabetize them or group them by functionality. And they can't do that if they have these private program units that have to occur in a certain order. So the workaround is actually that you can use this forward declaration, where basically at the beginning of the package body, you would forward declare anything that's in the package body somewhere else. I think there's one we can look at here where they actually just put the header to declare it, and then later on down in the package they can actually put the entire block if they're wanting to, like I said, maybe keep them in alphabetical order or something like that. Now, one-time only procedures are used, as it says, when the user needs a dynamic action to occur on the initial call to a package. And we're going to look at an example in a minute of one of these. So it may make more sense when we actually look at a live one. But anyway, the idea is that some action needs to happen basically when the package is initialized. And that might be that we need to go grab a variable at that moment, a value out of the database. Maybe we need to calculate something that's used inside the package. Whatever the reason might be, it's dynamic action. It can't occur until the package is being used. Think of like a system date. If you're wanting to pull in today's date into the package, then you could do that through these one-time only procedures, for example. But today, if we did it today and then used it 5 days from now, we need a different date. So that's what we mean by dynamic. It's got to be done right at execution. So what we actually do to do this is we create an anonymous block at the end of the package body, and it doesn't actually even have an end statement in the anonymous block. And then that basically executes on an initial call to use anything inside the package. So if you make a call to the package to use a function, and that's the first time that package has been used within that user session, then it's going to execute this one-time only procedure. And then 5 days from now, if you have a different user session, obviously, because you would have logged off and back on again, but in 5 days, we actually make our first call during that user session to the package, then it executes again. So, one-time only is a little bit tricky. It's not truly one-time only, meaning in the forever standpoint. It's one-time only within a user session. Again, kind of indicated by that log on, log off type thing. And we're talking about logging on and logging off the database. Keep that in mind as well, not necessarily the application. Now, a lot of times if you have a front-end application, the login actually goes and logs in to the database as well in the background. So, it could easily mean you're logging in or logging out of a database. But again, if we're using a web application, it might be like, for example, Google search or something like that. The user session might actually be initiated by the first time you use the website, and then when you close your browser, it gets ended, that user session. So anyway, just some logistics there. Let's see. Here's an example of what one looks like, and we're actually going to create one of these together too in a few minutes. But you can see it's just an anonymous block, and there's no end statement for it. So this one is begin, select amount into PV bonus num from BB promo, where ID promo equals B. So it's going to go get the current bonus amount, basically, for a certain ID. And for this particular example, the reason it needs to be dynamic is that our marketing department might be changing the customer bonuses or promotions that are offered. And so we need to go and grab the one that's currently being offered. So that's why the need for a dynamic would be good. We couldn't store that ahead of time. Now, the last topic we're going to talk about from the slideshows before we go and look at SQL Developer together is overloading. And we're going to have an example we're going to do together in SQL Developer for this as well. Overloading is actually the creation of more than one program unit with the same name. This is actually extremely useful. Basically, we might think of a search screen in an application, and maybe the user is given two options to search by. They can search by date, or they can search by product ID, or maybe maybe date and say sales order number, or by customer last name. Those are three different search criteria. One's a date, one's numeric, and one is a string, characters. And so basically we can use the same procedure or function to go do what we want it to do to return to the user, but we don't have to create three separate ones. We just basically differ them, the three ones that are named the same, by the type of input that they actually take. Now, they can differ, must differ by one of the following: the number of parameters, the parameter data type family, which is the example I was talking about, or the listed order. So basically the order that the parameters are accepted in. So it allows a particular program unit to accept a various set of arguments, is what I was trying to say. It says it pretty good there. The second bullet point, it says some Oracle supplied functions are already overloaded, such as the function toChar, because it can accept various data types as an argument. And overloading can only be accomplished with a package. So you have to put any of these program units that you need it to accept different types of arguments, they have to go inside the package. Otherwise, overloading doesn't work. Now, here's an example of an overload, and we're going to go create one ourselves in just a second. But if you look here, we've got two separate procedures in the package specification, the product search. They're both called product search. One has an in parameter of product ID. Actually, they both do. I think that's a typo. Oh, no, it's not either. They're just using it the same variable name. But anyway, we've got PID coming in that is actually the ID product type, data type, which would be actually numeric. And then the second one is based on product name, which would be character based or string based. So you can see there they even use the same input variable or parameter input name, but they did not, but they changed the data type that it's looking for. If you look down below again in the body, we have the procedure just repeated with the same name. And again, the end parameter is just different, of different data type. And then the first one actually does its select statement based off of the product ID, where ID product equals PID. And then the second one does it where product name equals PID. So again, one's accepting basically a search by ID, product ID, and the other one's accepting a search by product name. So that's kind of a good example there of overloading. Now let me go and share my desktop with you. And we're going to look at the challenge exercises and work through those together. The first one, challenge 7-1, is at the bottom of page 258. If you want to turn there while I'm getting my screen set up for you. Okay, you should be seeing my screen now. Notice that I have the Chapter 7, the BB Create script open. I have already run that for Chapter 7. Make sure that you have done that as well before you start Chapter 7 work. Now, if we look here at the challenge 7-1, it says we want to create a package containing the 2 program units in the following list. Test the package with a call using the procedure. Name the package prod_package. Okay. Now, in SQL Developer, a quick way to actually start a package is we can say File, New, and then in our new window we can choose Package. We used this method, I think, last time for our procedure or function. But we got a package. We have to say which connection, so I want to do it against my brew user. And then I name my package. So it tells me in the challenge that we want to name it prod_pkg. And then it goes ahead and gives us a template so that we can get it going here. And then we just replace, obviously, the comments in the middle with our actual code. Now, this is creating the package specification because the package specification or the package body cannot exist without a package specification. So we always start with creating the package specification. Now, in this particular one, it says we need to create a function and we need to create a procedure. And the procedure, actually it says the function, and let's go ahead and read this together. So we need to understand this before we decide what to do here. It says function, it accepts the product ID value, and it returns the product's current stock level. Okay, so basically we're going to go look up the stock level for a product based on product ID. It says this function should be private to the package. So for it to be private to the package, that means that we are not going to put it in this package specification. Okay, that way it'll be private to the package. Now it says name the function stk_pf. Then we've got our procedure. Our procedure accepts both a product ID value and the requested quantity. So the procedure needs to call the function and then determine whether there's enough stock available to fulfill the request for a certain product ID and quantity that someone's wanting to order. If there's enough stock, update the stock level, meaning that we're going to subtract out what somebody's taking away or purchasing. And if it's not, display a message that there's not enough stock, basically. And then it says this procedure should be public, so that means that it should be in our package specification. Name the procedure STK UP_PP. Okay? So the only thing that's going to go here in our package body is going to be our procedure. And it's called STK UP_PP. And it's going to have basically this procedure, it says, accepts two input parameters, a product ID and the requested quantity. Okay, so our first one is a procedure, so we'll do P_ID for our variable name, because that's the ID, and it's an in print. And then it's going to be the same as our product ID in our table. So we're going to use the data type where it goes and looks it up. BB_product dot ID product percent type. And, oh, I needed a comma, sorry, instead of a parentheses. So we have one more thing we need to accept as an in parameter. We need to accept a quantity. And that's just going to be something that our user is probably going to type in. So, or maybe it comes from another variable somewhere. So we've got P_quantity, QTY. And it's an in parameter, and it's going to be a number. Okay. And, oh, semicolon. We need my semicolon. So that's all we need to define our procedure inside of our package specification. And since that's the only thing going in our package, because the function needs to be private, then we are actually done with our package specification. Now, once you're done with it, notice over here under packages, it's not available yet. If we refresh, there's nothing there. That's because it hasn't been compiled yet. Okay, so if you notice some buttons here, the gears, just like we did with our procedure and our function where we compile them, what we want to do is go ahead and compile our package specification. Okay. And if you notice under here, your message log, it says compiled. And if we come over here to our package and refresh, we should now see it here. And notice the little green dot beside the product package there on the package itself. Looks like a little present. That green dot, though, indicates that it compiled successfully. There were no errors. If you have errors, then you would have gotten them in your message log. And then also you would see actually a red dot over there saying that it didn't compile successfully. Okay, and we can see in that package we have one procedure. Now we actually need to create our body. So if we right click on our package name, we can say create body, and it's going to give us our little template to get us started with our package body. Notice it automatically added in our procedure header for us. That's the nice thing about SQL Developer, is it gives us some shortcuts so we didn't have to type all of this. It also created our create or replace package body statement and the package name. And then we've got our procedure, a good start to it. We just got to fill in the begin section. And it already created the end for both of them, okay? Now, let's go ahead and work on the private function first, because it tells us inside our procedure definition that the procedure is going to call the function. This is an important example of the order that things go. We could not put the function definition after the procedure definition if we wanted it to compile properly, because our procedure is going to call our function. So we have to have our function definition first in our package body, because then that way Oracle or the database already knows about it before it goes and is called inside the procedure. So I'm going to come up here above the procedure and add some blank lines, and we're going to add in our function. So let's see, let's go ahead and tab this down. And then to begin our function inside of our package body, we just type the word function, and then we give it a name, which we are told to name it STK_PF for package function. And let's see, our function needs to have one in parameter. If we notice, it says it accepts the product ID variable, and it returns the stock level. The stock level is also going to be a number. So we've got function in the name, and then we put our in parameter, which is going to be our PID, and it's in, and it's going to come, its data type is going to come from the BB product table dot ID product, just like we did in the procedure. And actually, we could have copied and pasted if we wanted to save a little time typing here. So we've got our in parameter, and then our function is going to return a number. Actually, let me go ahead and space that in a little bit. Just trying to make this more readable for us. So our function is, then we've got begin. Actually, let's stop and think about this. Do we need a variable? We actually will need a variable in our function, because we need to store what's being returned. What's being returned is the stock number, the amount in stock. So let's call it local variable, STK for stock, and then num, we could do quantity, whatever we want to name it. But this is actually, its data type is going to be the same as the stock data type in our BB products table. So we'll use our %type so that it goes and grabs the correct data type. And then we have our begin section. Now let's think about it. This function needs to take the product ID and go and look up the stock level. So our main section, our executable section of our function, really is just going to have a select statement. So we want to select the stock into our local variable, and it's going to come from BB product table, and we want to limit it to where our ID product equals basically our input parameter of P_ID. And then we want to return we're going to return our stock number. So we're going to return our local variable STK_num, because that's what we're supposed to return out of the function. Now, just to show an example of a quick exception that we could throw in here, think about select statements. What if it didn't find anything and it found a null in our stock amount? So we can actually say have an exception section here. And our exception would be when no data found, then we would say return 0. Okay? Because think about it, if there's no data in the stock, then it would be the same as having 0 on the shelf. So that would be a really good exception to use here. Then we need to end our function. Now I'm going to do end, and then we're going to use the function name stk underscore pf, and we're good. Okay, that should be all good there. Now let's look at our procedure real quick. It says our procedure needs to accept both a product ID value and the requested quantity. We already set that up because we've got our header here. So actually, because we created the body from the with SQL Developer, we actually have all of that part completely done for our procedure. Now it says the procedure needs to call the function and then determine whether there's enough stock available to fulfill the request. So we're going to call this function that we just created, and basically we need to check the stock number that's returned against the quantity that our user input. If it's greater than or equal to the quantity the user input, basically our stock, we have enough stock, then we're going to go update the product and subtract out the quantity our customer is taking. Otherwise, we're going to say something like insufficient inventory or something like that, or not enough inventory or something, whatever we want to, since they don't tell us exactly. Okay, so in our procedure, in our begin, we have, first of all, we need to, well, let's go up. We're going to need to have a local variable in here as well. So above the begin, we need to have, again, a stock number, okay, that is used in our procedure. So we've got local variable stock num, and it is going to have this, again, the same data type as our stock column in our BB product table. So we can use that. And then let's think about what we're going to do. We're going to take that stock number and we're going to set the stock equal to the result of our function. Okay, so we need to go call our function. So we're going to use an assignment statement. So we're going to initialize our LV stock number variable. So we do the colon equals, and so it's an assignment statement, and we're going to equal that to basically whatever is returned from our function if we execute our function. So our function to execute, we would actually just type the function name, which is, let's see, stk underscore pf for package function. And if we go up and look at our input for that, our input is product ID, so we would do p underscore ID. Okay, so we've assigned basically this local variable stock equal to the result of our function we just created, our private function. Now, we need to do some comparison because we need to compare our stock to the quantity that the user has given us that they're requesting to purchase. So we probably want to do an if statement since we have a couple of scenarios. We want to do one thing if the stock is greater than the quantity, and we want to do another thing if the stock is not greater than the quantity. So let's go ahead and start our if statement. And we want to check our stock number. And we're looking for where it's greater than or equal to our quantity that the user has input at the keyboard. And so we've got our then. So if it is, we have enough stock, basically there's more stock on our shelf than the customer is requesting, then we want to update the stock level. So we actually would put in here in our if statement an update statement. Update BB product. That's what we're talking about here. And we want to set our stock equal to stock minus our p underscore quantity. Okay, because again, stock is what's already in the database. and we're going to subtract out what our user is purchasing, which is stored in the P_quantity. And we want to do this where the ID product in the table equals the product ID that's the input of the procedure here. So where ID product equal PID. And we need to commit this update statement. Okay, so let's go ahead and commit it. And then we can do our else, because remember, we're still inside our if. So else, and going back to our instructions, if the quantity, the stock is not greater than the quantity, then we want to display a message. So all we need is our DBMS output statement. And we'll just say insufficient inventory. And then we have end if. And then we don't need that null. That was put in there by the template. And then we end our procedure, and then we end our package. Okay. So, and notice how I used some spacing in here. I put a blank line between the procedure where I ended that. I actually put a blank line between our function and our procedure. And I just try to space it out as with the ending as well to make it a little bit more readable for us. So, again, there's not really a save. What we want to do is compile, and that's going to save it all at once. Notice we got the little green dot on the left-hand side in our connections window. So now we have that good. We know that that compiled correctly. We also can see here in our message log. And so now we can actually go and test it. I'm going to come over to Brew User to test it. And what we probably want to do is just call our procedure, because the function is called by the procedure. So all we need to do to test it is call the procedure itself. So I'm going to do that actually instead of typing a whole block. I'm just going to use another method that you can use in Oracle. You can use the execute command. Execute, and then we give the name of the package, prod pkg dot, and then the name of the procedure. Notice we're getting the little help there, stk up underscore pp. And let's try it with values of product ID 1 and 25. And let's see when we execute this what we get. It says anonymous block completed. Oh, I forgot to do my DBMS output. And that's my fault. We're not going to be able to see again. Let's see. Let's run it again. We probably will get insufficient this time. Yeah, we get insufficient inventory this time. We don't really know what happened the first time because we don't have anything. I didn't have the output turned on. But you can see here it worked because we're taking away 25 again, and it's saying, oh, there's not enough inventory left. Okay. So I probably should have gone and checked the inventory value for the stock for this product ID 1 before we started, so I'd also know what was going on a little bit better. So. Okay. Now, I notice I'm already at an hour. I always hate to keep these much longer than an hour. But let's look at challenge 7-2 real quick. And because it just adds a little bit to this one. 7-2 says modify the package created in challenge 7.1 to include a one-time only procedure that populates a public package variable with the next shipping date. The company ships every Wednesday. So that's why it's dynamic. Every week, that date needs to be updated to the next Wednesday. Okay? So if we look here at our package, we really don't need to make any changes to our package specification because the package specification just has our procedure header, which is there. Where the one-time only comes into effect is in our body. And if you remember, we said what we do for one-time only is at the bottom of our um, list of functions and procedures. So right before the end, we actually create an anonymous block. And then that gets executed the first time the procedure gets used. So our anonymous block, I'm going to end it after my stored procedure, would just have a begin section. And what it's going to do is basically just execute and store a variable name. Oh, wait, we do need to change the package to, I'm sorry, because think about it. We've got a new variable and we're wanting to store a ship date. So we actually have to declare that variable inside our product package specification too. So let's go ahead and create it here in the body, and we just won't compile. And then we'll go over and put it in the specification. But let's think about it. If we want to store a ship date inside a variable, we're going to call this PV for package variable ship date. And we're going to have an assignment statement in this anonymous block that's basically going to get what's the next Wednesday. Now, Oracle has a built-in function to do this. We covered it in CIT271 last semester, and that function is next day. It goes and gets the date of the next day, and what we have to supply it is, first of all, the next day after what date. So we're going to say sys date, so today's date, and we want it to be the next Wednesday. So that's the next day of the week that we're looking at. And what this will actually return is an actual date. Okay, so today is Tuesday the 19th. The next Wednesday is the 30th. Or no, excuse me, listen to me. I'm jumping way ahead. The 20th, I mean. Okay, so it should return tomorrow's date to us if we execute this today. Okay, and then we actually don't have to end our anonymous block either, if you remember. Okay, so we just put in our begin section. Now, we can't compile this because if we could actually, but if we compile it right now, then this would be private, this variable, this ship date. If we want the ship date to be available outside of the package, then we have to add it to the product package specification. And actually, it doesn't really say that whether it should be, it does say a public package variable. Since it's going to be public, we have to come over to our product specification and add the variable over here, which we called it PV underscore ship underscore date. And it is going to be a date variable or data type. Okay, so we have to add it here to the specification for it to be public. Now, because we've modified both of these, we should compile the package specification first. Okay, and notice that once I compiled the new product specification, it's telling me there's a problem with the package body. That's because I haven't, we see the red X there. That's because I haven't, updated to the new version of the body. So now when I compile the body, I'm actually get green dots for both of them. So I know they both compiled correctly. Okay, and then we could go test that if we wanted. I'll leave that up to you guys to try on your own to test it, since we're running short on time. Now, I had wanted to get to challenge 7-3, and I might do that another day. It's basically doing an overloaded package that accepts shopper ID or username and returns the shopper's name and count. So basically, and it doesn't even tell us if it wants us to use a function or a procedure. We could do either, actually, if we wanted. So try challenge 7-3 on your own. If you get stuck with it and can't figure it out, email me. And I might hop on later this week and record the solution to that one. But try it on your own and see if you can figure it out. And we'll go ahead and stop for the day since I've pretty much hit my hour. But I hope you guys are doing well and enjoyed spring break, and you're ready to get focused for the rest of the class that we have left. We really are through a lot of the meat of the material. We've got some more things to wrap up in a couple more chapters, but then we'll be focused on the final project. for the course, and hopefully that'll be something fun for you. It will be completely hands-on, and it will be something I give you guidance for. Um, there's some flexibility with it, but it's not like you've got to come up with a topic completely on your own. So we'll be talking about that in the next few weeks as well. So I hope everyone has a good week, and I will talk to you soon. Thanks.